but I'll do my best. We have a program that is about to begin, which it's another ultra-deep field, this time in infrared wavelengths, that will probe as deep as we're able to probe. I'm not sure of the status of that, but it's imminent to its beginning. But what we all have noticed in these images, again, is you take an image of a Stephan's quintet, or you take an image of one of the other objects that we looked at, and off in the background there's all this stuff. There are marvelous details, including going down to small unresolved red blobs. And we know those small unresolved red blobs, in some cases, not in all cases, are distant objects. Now, they're not nearly as distant as we're going to be probing with the ultra-deep fields, because these are relatively short exposure times. But you can already see remarkable differences between what we're seeing now and what we saw with the prior instrumentation, just in this ability to see, oh, look what's in the background. My goodness, I didn't realize that was there. So it's not a quantitative answer, but it says that we're really sensitive, maybe even more sensitive than we thought we were.
Okay, thank you. And to follow up, maybe for Heidi, given the bigger picture, especially the two beauty shots of the Eta Carina and the butterfly, you see these sort of glows, this backlit glow that almost seems heavenly in a way. One, can you just, for someone who keeps looking at these type of images, does it lose the magic and the luster for you, or how beautiful is this to someone like you who watches us all the time? And just the glow, what is that? Because some people might see a little bit of, might find some spirituality in that.
I don't think we ever lose the awe and wonder. I mean, I've looked at hundreds of pictures of Jupiter, but when I saw the first images of Jupiter come back from this impact site just a month ago, all we could say was, wow. You don't lose the wonder. You don't lose the glory. The beauty is there to be appreciated in each new image that comes down with Hubble. And as we use Hubble over the next many years, looking at things that we haven't seen before, with our new cameras probing deeper than we've seen before, there'll be even more wonders for us to look at. So I think it's fantastic. We're not losing. You don't get jaded. You just keep being enthralled with every new image.
Thanks, Heidi. Real quick caveat to the briefing. My apologies to the STS-125 crew. We are going to go a little bit long, but we will get you on here. Also, we're probably going to have to limit follow-ons because of the number of media that we have wanting to ask questions. And finally, to the panelists, if you would, try to keep your answers as brief as possible. You can't answer the question, but try to hold it down if you can. And with that, any other questions here in the audience? All right, Joel here in the front from the Washington Post.
Yeah, quick question. Joel Achenbach with the Washington Post. Ed, with this mission being so tremendously successful, this servicing mission, is there any new impetus for serviceable telescopes, particularly with the Augustine Commission looking at some new ideas for the strategy ahead involving this deep space capability where you might be able to go out to 1 million miles out?
All right. Well, all we've got so far is executive summary for the Augustine Commission, so it'd be premature to comment. We're waiting until we get the full report, and then we'll be working with the OMB and the Office of Science and Technology Policy of how we would respond to it. But ultimately, now I'm not speaking specifically about the Augustine Commission, but ultimately, if you're talking 20, 30, 40, 50 years from now, I mean, in this century, we're going to have the capability of finding a planet that we can say has life on it. There's no question we have the technology to do that. The trouble is that takes very large telescopes, perhaps even interferometers. And I have at my gut level, my own personal opinion, not speaking for NASA now, is that the way we're going to build those new telescopes is probably assemble them in deep space, because you want to be far away from the Earth. So, there is a future for construction, of large things in space, but it's a long way down the road. And we'll have to see how, the Augustine Commission comes out and whether that's part of the near term or far-flung future.
Thanks, Ed. And now we're going to our field centers in Houston and Texas for Media Reporter.
Hi, Robert Perlman with CollectSpace.com with a question, I think, for David. You mentioned an ultra-deep field coming up, but can you give a preview as to what other images might next be coming? I guess Hubble's supposed to support the L-cross impact. What other targets are on the horizon?
Yeah, we have just begun the process of doing science with our newly recommissioned instruments, and we're in what's called Cycle 17, which is approximately a year long, and it's a pre-selected, peer-reviewed, scientifically excellent observing program. So what I can tell you a little bit about there is that, for one thing, we're all interested in Pluto and is it a planet or not, and we know that there's a whole population of Plutoids, Pluto-like objects out in the Kuiper belt beyond the orbits of Neptune and Pluto. So we're going to be doing a large survey to try to understand more about our own outer solar system. We certainly are going to be using the Space Telescope Imaging Spectrograph and the Cosmic Origin Spectrograph and the NICMOS when it comes back online to continue looking at the atmospheres of planets around other stars. We had shown some success in coming up with information about the chemical composition of exoplanets, and we're certainly now well postured to push that forward. There's almost no area of astronomy. I mean, I can't cite the Cycle 7 observing program off the top of my head. That is online, by the way, at the Space Telescope Science Institute website, if you'd like to see the whole rundown on them. But all I can tell you is that there are particular themes for which the door was opened by prior Hubble observations, and now we're well postured to walk through the door. And the exoplanet atmospheres is an excellent example of that.
Thanks, David. Now we're going to go down to Florida with a reporter at the Kennedy Space Center.
Hi, everyone. It's Bill Harwood with CBS News, and I'll ask this question to any of you, and it's the question that you get asked every time there is a Hubble news conference, but I'm going to ask it one more time, which is, with the new capabilities that HST now has, how does Hubble fit into the firmament of major telescopes on the planet and elsewhere? In other words, the big monster scopes that are coming online downstream. Where does Hubble fit in with all of those guys with the capabilities you now have? Thanks.
Well, physics rules, and I'll pass it to Heidi, but physics rules. We have an atmosphere to look through. Okay, there are ways to mitigate the atmosphere called adaptive optics, where you have rubbery mirrors which try to correct for the atmosphere. The trouble is you can do that, you can do it very effectively. These large telescopes will have better resolution than Hubble, but over very, very tiny fields of view. I cannot, unless somebody can correct me here, I cannot conceive of taking a picture of the Eagle Nebula with adaptive optics and getting the resolution that Hubble has. Ultimately, as the telescopes get to be 10, 20, 30 meters, they will have more light gathering power than Hubble. They'll be able to go deeper. But then we've got something up our sleeve called Jim Webb Space Telescope, which will start the race all over again.
The other thing that Hubble can do that can never, ever be done from the ground is imaging in the ultraviolet and imaging in some of the infrared, near-infrared wavelengths of light, because our Earth's atmosphere absorbs the photons before they get to the surface of the Earth. So you could make a football-sized field telescope and you'll never collect the photons because they aren't there. So Hubble is absolutely unique, and we must have a telescope in space to complement the very large telescopes on the ground. Hubble is absolutely unique at those wavelengths. Nothing else can do it.
We're going to stay out at Kennedy right now.
Hi, it's Peter King at CBS News Radio, and I guess I'll ask this of Dave Leckrone, and this is kind of a big picture, projecting ahead by maybe 100 years. When we have some of those bigger, better telescopes, maybe that are built millions of miles out in space, how will history look back on what Hubble has done in its first 25 years or so?
Well, of course, we need to be humble, and we need to, but in all humility, I truly believe that Hubble has fundamentally changed the course of modern astronomy and astrophysics, and is taking it in new directions. And new discoveries will reorient the path of science in other directions. But I think we have basically I don't